Hello everyone, I am Dr. Bilikul and today we will discuss solubility product of sparingly soluble salt. We have seen many kind of salts like sodium chloride, magnesium chloride, lead iodide, silver chloride, lead carbonate, silver carbonate, like kind of. But these salts are not same kind. These salts are having their different tendencies, like some of the salts are ionic in nature and some of the salts are not that ionic in nature. For an example, the salts of the first group and second group, most of the time first group elements are highly ionic in nature, their ionic character is very high, hence they are very easily soluble in the water because water is also ionic. In the same way, the second group salt, some of the salts like carbonate, magnesium carbonate, barium carbonate, calcium carbonate, these some of the salts are there which are not soluble in the water. Why they are not soluble in the water? Because of their covalent characteristics. And these salts which are not soluble in the water, or I can say not, I can't say that they are not dissolving in the water. They dissolve in water to a very little extent. And these are salt which have tendency to dissolve in the water to a very little extent are called sparingly soluble salt. So listen to it carefully. The salts which dissolve in water to a very little extent, they are called sparingly soluble salt. For an example, we have silver chloride. These kind of salts are silver chloride. We have lead iodide. We have barium carbonate. We have seen them as insoluble in the water salt, but actually what happens is they are not insoluble, they are very less soluble. So let's see one example how they dissociate and how we are going to find out their constant called solubility product. So this is, suppose I am taking silver chloride and this silver chloride is going to dissociate into its ion. So this is aqueous hydrated ions and chloride. This is also aqueous or hydrated ion. So basically silver chloride will give you two ions, silver ion and chloride ion. But these ions will be so small in number that after releasing very few ions, it will come in the equilibrium, that this salt and these ions will come in equilibrium. And just because they are in equilibrium, we can apply the concept of equilibrium constant. तो मुझे इसका equilibrium constant कैसे निकालना होगा? K can be considered as silver ion concentration and chloride ion concentration divided by silver chloride. And what is the silver chloride ion concentration? We don't consider it as it is changing. There is no, this is considered as unity because it is solid state. So this is, I am going to shifting this side and this becomes constant. And this constant KSP it is called. So what is KSP? KSP is the, yes, ionic solubility product is the product of ions of the salt, product of ions raised to power, concentration of the product of ions raised to power their stoichiometric coefficient. I don't need here kind of a stoichiometric coefficient because I am not, they are 1 and 1, stoichiometric coefficient is 1, but actually if there would be any stoichiometric coefficient, I would have used their Cl minus Cl raised to power something, isn't it? So this is what solubility product of silver chloride. I hope it is clear to you. One thing you have to remember here, that we are taking the saturated solution of any sparingly soluble salt. Saturated solution matlab more than that particular amount is not going to get dissolved. तो maximum हम जितना dissolve कर सकते हैं, after the dissolution of that amount we are taking this solubility product. Is it okay? तो maximum amount. What is solubility? Solubility is the maximum amount of that substance which can be soluble in a given amount of solvent. Okay? So this is what solubility product. Let's take one example. Let's solve one question so that you can understand this concept. I am taking the same salt, silver chloride, and you are given that the solubility of silver chloride is 1.06 into 10 raised to power minus 5 moles per liter. So you are given that this is the solubility of this silver chloride. So you have to calculate KSP for AgCl. How you are going to calculate the KSP? We have seen right now that KSP is equal to concentration of silver ion concentration of chloride ion. And what is the solubility here? 1.06. Solubility means what? Solubility means that these moles have been dissolved. कितने moles dissolve हुए हैं? तो 1.06 into 10 raised to power minus 5 moles are dissolved. तो जितने moles dissolve हुए हैं, these are going to convert into silver ion. So this is the concentration of silver ion, and same will be the concentration of chloride क्योंकि इनका stoichiometric coefficient is 1. So what will be the concentration of silver ion? 1.06 into 10 raised to power minus 5. ठीक है, multiplied with 1.06 into 10 raised to power minus 5. Same रहेंगे because both of them are 1 mole. 1 mole of this is breaking down to give the 1 mole of this and 1 mole of this. So what will be the answer? 1.12 into 10 raised to power minus 10. Powers will be added. ठीक है, so this is the KSP value for the silver chloride जिसके लिए molar concentration is 1.06 into 10 raised to power minus 5. मतलब इतना amount of the silver chloride is dissolved in the water only. And this is a saturated solution. Saturated solution means you cannot dissolve more than this. That is called the solubility. है ना? Maximum salt which can be dissolved into the water, into the given amount of the solvent, that is called the solubility of that solute in that particular solvent at that particular temperature, किसी भी given temperature पर. ठीक है, let's take one more example. This time I am not taking the salt which is having stoichiometric coefficient 1:1 का, लेकिन I am taking the salt aluminium chloride. So let's take aluminium chloride. So this time I am taking aluminium chloride. How it is going to dissociate? Aluminium ions and chloride minus ion. Balance the reaction. It will release 1 mole of aluminium chloride. If it dissociates, it will give you 1 mole of these ions and 3 moles of this ion. 3 mole of this ion. So this is what the scenario is. Now this time you have to consider the stoichiometry of the reaction. So what is given to you? Suppose the solubility S moles per liter is the solubility of aluminium chloride. Now what will happen? If S mole is dissolved, S mole will be of the aluminium will be formed and 3S mole of chloride will be created here. How I am going to write down the KSP then? KSP will be written as aluminium ion raised to power their stoichiometric coefficient. So this is 1, and chloride ion raised to power their stoichiometric coefficient. What is the solubility which is given in the moles per liter? So this is the concentration which is, क्योंकि this is the solubility, तो solubility is the concentration because these are the ions which are going to be dissolved. जितने मोल ये टूटेगा उतने ही मोल these ions will be released. Okay, so accordingly these ions will be released. So solubility is S. ठीक है, and solubility of chloride ion is 3S raised to power 3. So this is S multiplied by 3 3s and 9 3s are S3. So what is our answer? 27S4. So you can see there that solubility of aluminium chloride is different. So the type of salt will decide ki what will be the solubility of that salt in the water. So solubility will be decided by type of salt. So we can write down, if you want to like make a chart of this, you can write it, you can make the chart of this kind. Like if it is AB kind of salt. What kind of salt? AB kind. AB kind means like AgCl which we were talking about. AgCl kind of. So this will, the solubility will be, कैसे होगी? Solubility will be A का ion concentration, P का ion concentration. Okay, and then solubility will be S into S and it will be S2. So silver KSP for these kind of AB kind of salt will be K S2. Okay, if your salt is AB2 kind of, then what? इसकी solubility होगी A plus and B minus and raised to power 2 concentration, and then it will give you S into 2S2, and then it will give you you 4s3. This will be the solubility of these kind of, okay, like PbI2. If I calculate the solubility product for PbI2, I get it 4s3. Whereas this is the solubility. Molar solubility means mole per liter. Okay. Same way if I calculate it for the A2s kind, A2B kind of, then what will happen? A plus and B minus. A raised to power 2. Then solubility will be 2s raised to power 2 and B means S. Okay, so what will be the solubility? 4s3. Same way if I calculate it for the different kind of this kind. So this is AB3 kind of. If it is AB3 kind of, तो कैसे निकालेंगे? A my plus raised to power 1, B minus raised to power 3. And right now we have calculated it like S into 3S raised to power 3. And it becomes 27S4. So I think now you can calculate the KSP for the variety of the salts given to you. Variety of the salt depending on what type of salt it is, you can calculate by using the simple concept given there, that is how it is dissociating to give you the different kind of ions, that how many ions it is releasing. So let's take one example. Let's see the question first. The question is that calculate the solubility of zirconium phosphate in the pure water. Okay, so you have to consider that no ion in the water is reacting with the zirconium phosphate. Yani the phosphate is not reacting with the water. They are soluble, just soluble in the water. Solubility product is given to you, that is 1.1 into 10 raised to power minus 23. Okay, so KSP is given to you and solubility is asked to you. So first of all we have to understand what type of salt it is. AB type, AB2 type, AB3 type, yeah, whatever it is. So let's see how it is going to dissociate. Zr3PO4 whole 4. How it is going to give its ion? Zinc के zirconium 3 ions and phosphate 4 ions are being formed. And one more important thing, zirconium, the charge on the zirconium will be 4 and phosphate will be minus 3. So this is 4 plus how many ions? 3 plus phosphate ion PO4 3 minus and how many ions? 4. So this is how the zirconium phosphate is going to break down. Okay. Now what will be the solubility? We know this, the solubility, if I am considering solubility as S, so this will be 3S and 4S. If I write the KSP, so KSP will be 3S raised to power 3, 4S raised to power 4. Okay, so this becomes 3 3s and 9 3s are 27 into 256 S 4. If you multiply 256 4 and I forgot to mention this as 3 into S3. If you multiply this 27 with 256, 6912 S4 plus 3, that is 7. So this is going to be KSP for this zirconium phosphate. ठीक है, अब क्या करना है? What is the solubility? You are given, you have to calculate the solubility. You are given 1.1 into 10 raised to power minus 23. So what will be the solubility? Solubility will be this KSP divided by 6912. So 1.1 into 10 raised to power minus 23 divided by 6912, and this is solubility will be 1 by 7. So this is how we are going to calculate the solubility of zirconium phosphate. The main thing here is see how many ions are being released. कितने ions release हो रहे हैं, that is important. And the number of ions, just consider it. Either you just learn the formula like this, direct formula learn कीजिए. For the AB kind of it is S2. For the AB2 kind of it is 4S3 like this. For the A2B kind of it is 4S3. For AB3 kind of it is 27S4. Or for the type A3B4 we have 6912 S raised to power 7. So this is the formula which you can learn either you can learn it or you can solve it that how it is dissociating, and then you can find out that 6912 S7 equals to KSP for the change for that particular salt. So this way you can calculate the KSP for the given sparingly soluble salt. So now I am taking one more question here. Here is your question. Question is saying that calculate the KSP for the silver chloride अगर solubility of silver chloride is 1.435 grams per liter. So you are giving the solubility in grams per liter. This is important here because you need to have you need to write down the molar concentration, because in formula you are supposed to write down the molar concentration. Okay, so here you are giving the solubility in grams, so we have to first convert the grams into mole. So what is the substance? We have AgCl. Grams में convert, grams को mole में if you want to convert, we have to know the molar mass of AgCl. So mm of AgCl will be what? Silver is 108 plus 35.5 is the chlorine. So it becomes 108 and 5 plus 8 9 10 11 12 8 9 10 11 12 13 13 से 1 4 143.5 क्या grams per mole. So this is the molar mass of silver chloride. Now what is given to you? You are given the solubility in grams per liter. So you know that the molar mass is this. So when you calculate the moles, you can convert the moles into, so the number of moles of silver chloride here per liter, that is W by mm. So W is what? 1.435. mm means 143.5. So what is the answer? You will get it like 2 10 raised to power minus 2. ठीक है, आपका आ जाएगा 0.01 answer. So this is the solubility of silver chloride in water. ठीक है, now we have got this number of moles per liter मिल गया आपको, molarity मिल गई, moles इतने moles हो गए. Now what? Now just apply what kind of substance it is. It is AgCl. It is AB type. AB type के लिए it is KSP equals to S2. तो KSP equals to S2. What is S? S is this. This is the solubility, the number of moles which are present in 1.435. So this is 0.01 into 0.01. So this is KSP. That is 10 raised to power minus 4. Will be the KSP of AgCl salt. So I hope this concept of solubility product is clear to you. If you like this video, please hit the like button, share it and subscribe my channel. Thank you very much.